Welcome to the Phys2 lab. This is our second week working with the Coulomb balance apparatus. Today we're going to measure the electric force given between two charged spheres. So we've got the calibrated Coulomb balance that we had last time. You remember the dial set to 0. These index lines should line up. If they don't, you can gently rotate this at the base. Just don't unscrew that screw at the bottom until those index lines come back together. Now we have to check to make sure that the center to center distance of this track is calibrated properly. To do that, the spheres have a diameter of 3.8 centimeters. So if they're perfectly touching, just barely touching, the center to center distance is 3.8 centimeters. So if I move this to 3.8 centimeters and I give this a twist to keep the swinging sphere, sphere number 1, pushed against sphere number 2. Now I can check to make sure these index lines are once again lined up. If they're not, you'll have to adjust the length of this straw. If you have any questions about that, call your instructor over and you can get that set up properly. So let's push these spheres far apart. We'll go through the charging process and then measure the force on between the spheres. You see the kilovolt power supply, that's what we'll use to apply charge to these spheres. The ground, the negative terminal, is connected to the line supply ground. Make sure that that's connected as a reference. And then the other wire is available if you would like to ground your spheres. Just touch the wire to those spheres. Oh, very gently. Very gently. All right. We turn this on. We set the voltage to the desired voltage. I'll put this at 6 kilovolts. And now we've got our probe with tiny little whiskers of wires. We use fine gauge wire because there's a strong electric field at the tip, and that will help us apply the charge. We want to brush that charge on the spheres, maybe 2, 3, or 4 points around on the spheres. We turn the power supply off, and then we set the distance to be the number that we require. Now, there should be some repulsion between the spheres. You will dial this to oppose the twist from the electrical force, and the twist angle is going to be proportional, as we saw last week, proportional to the force that you're balancing. So that's how we measure the force between two charged spheres with a given distance r between them.